In this part, we will explain the method of conducting the calibration on parameters and discharge data resulting from the simulation in ArcSWAT by using the SWAT CUP program and observed discharge data for the study area, whereas we have the monthly observed discharge data for the period of 2 years. We have already prepared them as entries into the SWAT CUP program in the manner described in the previous part, whereas this data is contained in the Excel file entitled Observed Data for SWAT CUP, and in it we find monthly observed discharge data for 2 years intended for entry into SWAT CUP program, as we see. And now we are conducting the calibration in the SWAT CUP program as follows. Whereas the monthly discharge data resulting from the simulation and the ArcSWAT program is located on the desktop in the following path. SWAT project, scenarios, monthly, tables out inside the Access file titled SWAT output.mdb, and then inside the table titled RCH, as we see. Now we go to the SWAT CUP program and we open it. And in it we go to start menu, and in it we click on new. A window titled new report wizard appears, and in it we press next. Then we go to TXT in out location, and in it we go to the following path. Desktop, SWAT project, scenarios, monthly, TXT in out. Then we press open, and then next, then we go to SWAT version and we choose 2012. And in the processor architecture we choose 64-bit. Then next, then we go to project type and we choose SUFI2. Then next, then we go to project name and we type LZRB. Then we select the project location on the desktop, where we click on make a new folder, and we type the name of the project, which is SWAT CUP C, as we see. Then we press OK. Then we click on finish. The paragraphs regarding the implementation of calibration appear in the Project Explorer, and in it we go to calibration inputs, and in it we press PIR-INF.txt parameters, and the main parameters used to perform calibration appear, which include CN2 alpha-BF, GW-delay, and GWQMN, as we see. Whereas the parameters required for the case that we have in the Excel file titled SWAT Calibration Helper, where weak value of statistic parameters appeared as we see, where by going to the tips-hydrograph page, the case that we have falls under issue 4 and solution for it are adjust alpha-BF, adjust infiltration parameters, and adjust parameters determining interflow. And here alpha BF and GW delay are present, where we adopt these parameters, and in number of simulation we choose 30. Then we go to SUFI-SWEdit.def, and in it, in the ending simulation number, we put the same value of the number of simulation, which is 30. Then we go to observation, then we press RCH, then we click on observed-rch.txt, and in it we go to number of observed variables, and we put 1. Then we go to the flow out, and in it we put the subbasin number, which contains the observed discharge data values, which is 4. Then we go to the number of data points, which is 24. Then we activate the old data and we make for it delete, as we see. Then we go to the monthly observed discharge data for 2 years, intended for entry in the SWAT CUP program in the manner described in the previous part, where we make for it copy and transfer it to the SWAT CUP program through paste. Then we go to the extraction, then var file rch.txt and set the value of flow out to subbasin number 4. Then we go to SUFI2-extract-rch in the number of the variables. We put 1. In the variable column number we put 7, and in the total number of reach, and according to the information we have in the access file, we have 7 subbasins, and accordingly in total number of reaches we put 7. In the number of reaches, to get the first variable we put 1, and in the reach subbasin we put 4. Then we make delete for the next 2 lines, and in the beginning year we put 2003. In the end year of simulation we put 2004, and in the time step, which is monthly, we choose 2. Then we go to objective function and we click on observed.txt, and in it we go to number of observed variables and we put 1. In objective function type we choose it according to R², which is 3. In flow-out we put 4. In number of data points we put 24. In number of data points we put 24. Then we activate the old data and we make for it delete, as we see. Then we add the monthly observed discharge data via Ctrl V. Then we press var file name.txt and set the value of flow-out to subbasin number 4 at Dokan Dam site. Then we save the project by pressing on save. Then we start to execute by pressing Calibrate or F5. Then we press execute all. Then we type yes or Y. Then we press enter. Then we press OK. Then OK. We wait for the calibration to complete. Then we press OK. Then OK. Then OK. Then yes. Then we type the iteration name, say A, then OK. In the Project Explorer, we go to iteration history. And we press iteration A, and we go to calibration outputs. Then we press 95 PPU plot, and we note how close between the observed and base simulation. Then we click on summary statistics, and in it we find that R² 0.92, NSE 0.77, RSR 0.48, and P bias minus 13.8. And according to the performance in the Word file entitled Statistic Parameters, the P bias value falls within this range and the performance for it is good, but we want the performance to be very good, as well as in the first table, according to P-bias, RSR and NSE, the performance for it is good, but we want the performance to be very good. To do so, we repeat the calibration in SWAT CUP, where we go to Project Explorer, then to Calibration Inputs, then to Objective Function, then to Observe It, and in the Objective Function type we choose P-bias, which is 8. Then we save the project by pressing on Save. Then we start to execute by pressing Calibrate or F5. Then we press Execute All. Then we type yes or Y. Then we press Enter. Then we press OK. Then OK. We wait for the calibration to complete. Then we press OK, then OK, then OK, then yes. Then we type the iteration name, let's say B, then OK. In the Project Explorer, we go to iteration history and we press on iteration B, and we go to calibration outputs. Then we press 95 PPU plot, and we note how close between observed and best simulation is. Then we click summary statistic, and in it we find that the R-square 0.82, NSE 0.8, P-bias minus 9.4, and RSR 0.44. To improve the results, we repeat the calibration in SWAT CUP, where we go to the Project Explorer, then to Calibration Inputs, then to calibration input, then to parameters, and in it we find 4 parameters, which is not enough, where we add another parameter to them. The parameters used to improve surface runoff and sediment are in the Word file titled Parameters Most Used for Calibration of the SWAT Model in Anticipation Runoff and Sediment Yield, and in which the parameters of type GW delay and alpha BF are present. The other parameter that needed to improve the calibration process is SOL-AWC, which is available water capacity of soil layer, which affect the value of curve number CN2, where we choose this parameter with the title SOL-AWC, which has a value from 0 to 1, where we go to a SWAT CUP program and click on add a new parameter. A window entitled parameter browser appears, and in it we go to parameter name and we type SOL-AWC and we select it. Then we press OK. Then we go to number of parameters and we type 5. And in the SOL-AWC parameter, we specify the min 0 and max 1. Then we go to objective function and we click on observed.txt, and in it we go to objective function type and we choose it according to R-square, which is 3. Then we save the project by pressing save. Then we start to execute by pressing calibrate or F5. Then we press execute all. Then we type yes or Y. Then we press enter. Then we press OK. Then OK. We wait for the calibration to complete. Then we press OK. Then OK. Then OK. Then yes. Then we type the iteration name, say C. Then OK. In the Project Explorer, we go to Iteration History and we press Iteration C and we go to Calibration Outputs. Then we press 95 PPU plot and we note how close between observed and base simulation is. Then we click on summary statistic, and in it we find that the R-square 0.92, NSE 0.77, P bias minus 13.8, which is greater than 10, then the performance is good. And RSR 0.48, to improve the results, we feed the calibration in SWAT CUP, where we go to Project Explorer, then to calibration inputs, then to objective function, and we press observed.txt, and in it we go to objective function type, and we choose it according to P bias, which is 8, and the parameters number is 5. Then we save the project by pressing on save. Then we start to execute by pressing calibrate or F5. Then we press execute all. Then we type yes or Y. Then we press enter. Then we press OK. Then OK. We wait for the calibration to complete. Then we press OK, then OK, then OK, then yes. Then we type the iteration name, let it be D, then OK. In the Project Explorer, we go to iteration history, and we press on iteration D, and we go to calibration outputs. Then we press 95 PPU upload, and we note the extent of the convergence of observed and best simulation. Then we click on summary statistic, and in it we find that R-square is 0.82, and P bias minus 9.4, and it seems that there is a mistake, so we check the inputs, where we go to Project Explorer, then to calibration inputs, then to parameters, and in it we find that there is a mistake, whereas the max value for soil for SOL-IWC parameter is 0 and must be changed to 1 as we see. Then we save the project by pressing on save. Then after correcting the error, we save the project using save. Then we start execution by pressing calibration or calibrate or F5. Then we press execute all. Then we type yes or Y. Then we press enter. Then we press OK. Then OK. We wait for the calibration to complete. Then we press OK, then OK, then OK, then yes. Then we type the iteration name to be E, then OK. After correcting the error, we preview the result where we go to Project Explorer. Then we go to iteration history and we press on iteration E and we go to calibration outputs. Then we press 95 ppU plot and we note how close between the observed and this simulation is. Then we click on summary statistic and in it we find that R-square 0.87, NSE 0.78, P bias minus 1.1 and RSR 0.47. According to these results, the performance of this hydrologic model is very good, as we see. Thus, we will adopt these results in iteration E in the calculations and conduct future analysis. Now, we save the project by pressing on save. And these calibration results are found on the desktop inside the file entitled SWAT CUP C, in which we go to iteration E and then to SUFI2 out, and in it we open the file titled best-pdf PIR.txt, and in it we find the best parameters. Then we open the file titled best-sim.txt, and in it we find the values of monthly observed discharge data and monthly simulated discharge data. As we see, the same result for the latest iteration are available here inside the file titled SUFI2 out. As we see, to make sure that these results match the monthly simulated discharge data with the monthly observed discharge data, we open this result in Excel program, and in it we go to File, Browse, Desktop, SWAT CUP C, LZRB, Iteration, E, SUFI2 out. Then we choose all files. Then we choose best-sim.txt. Then we press open. Then next. Then we tick on space. Then next. Then finish. The results appear in Excel program. Where we activate the monthly simulated discharge data and we make a copy for them, and we go to Excel file titled SCH or SWAT Calibration Helper, and in it we go to a flow data page and we add the values of monthly simulated discharge data in SIM field via paste. Then we go to calculator page and we note the improvement in the statistic parameters in calibration field, as we see. Where the results became very good and identical, and thus we have obtained best calibration of parameters and discharge data resulting from simulation in ArcSWAT by using the SWAT CUP program and observed discharge data for the study area.